Going on, guys? In this video we are going to see an example of phasor. In this particular problem we have asked to find out the current in time domain. Here we have the circuit in time domain. We are going to convert this one into phasor. Then we are going to find out the current in phasor, and then we convert that current back into time domain. But before we do that, we have to know what's going to happen to this voltage, resistor and this inductor when we convert this one from time domain to phasor. Okay, now let's look at an example. Let's say we have Vm cos omega t, and if we convert this one into phasor, we have to have an angle. Like when we don't have the angle given, this is going to be just 0 degree, right? So we are going to have Vm cos omega t plus 0 degree, and when we convert this one into phasor, this is going to become Vm and the angle 0 degree. Okay, and this is the first thing. Now let's see what's going to happen to the resistor. So when we convert the resistor from time domain to phasor, it's going to remain the same, still going to be the same value. Okay, and when we convert this inductor to phasor from time domain to phasor, if we say this is L, this is going to turn into j omega L. Okay, so these are the things we have to know, and also we have to know what's going to happen to the current. Let's say we have Im cos omega t plus 30 degree, and if we convert this one into phasor, this is going to become same as this one. We are going to have Im and the angle 30 degree. Okay, so these are the things we need to know before we do this problem. Now we can go ahead and do this problem. Let's draw the circuit in phasor. Okay, here we are going to have this circuit like this, and our new voltage is going to become this first value. This is our Vm value here, the first value 5, and the angle. So this is going to be our new voltage, plus minus 5 7 degree. Okay, this is our voltage, and the resistor remains the same. Resistor remains the same. That's going to be just 50, and here we are going to have this j omega L, but let's put this one in box. Okay, because when we convert this resistor, this inductor, this is going to become impedance, so we can put it as a box. So this is going to be 50, and this is going to turn into j omega L. In our case, omega is the value that multiplies the t. If you look at this equation, this is our omega, that value that multiplies the t. In our case, that's going to be 10, right? So omega is equal to 10, and we know the inductance, that is 3 times 10 30. So j omega L, j times 30, so that's going to be just j 30. Okay, so these are the things we need to know, and these two are impedance right now. This resistance and this inductance is impedance. So when we have resistance in series, we can add them together, right? So we can do the same thing here. When we have impedance in series, we can add them together. So this is going to turn into 50 plus j30. So instead of writing like this, we can combine them together and write it like 50 plus j30. Okay, so this is our circuit. Now we are going to find out the current, and normally you know that Ohm's law, V is equal to IR. When we have in phasor, this is going to be V is equal to IZ. Okay, and we have to keep the I in capital in phasor. Okay, in time domain this is going to be small I. This is the one we are trying to find, but let's find out this capital I first, then we are going to convert this one back into time domain. So V is equal to IC, therefore I is going to be equal to V over Z. In our case, V is equal to 5 7 degree, and then we have the impedance, that's going to be 50 plus j30, and if you calculate this value, you will get 0.086 let's write this one clearly, 0.086 negative 24 degree. And to convert this one into time domain, you have to do this backward, because this is our phasor term, right? Im 30 degree. If you want to convert this one in backward, you had to do this one, like we had to have Im cos omega t plus 30, and if we write this one in that way, I is going to be equal to, Im is going to be this first value, that is 0.086, and then cos In our case omega is 10, so 10t, and then we are going to have this new angle that is negative 24 degree. Okay, and that's gonna be the current in time domain, and that's how we do this kind of problems. I hope this helps. Thanks for watching.